Continuing on from lesson 8.2, we'll look at some examples here. So we talked a lot about the sine and the cos graph, and I've been using this term sinusoidal function. The sinusoidal function is any graph that looks like a sine graph or cos graph, which we've talked about being very similar. Okay, so let's take a look at this example. This is, I guess we could call it a real-world example, where this graph represents the path of someone who's on not a roller coaster, but a Ferris wheel. Okay, so if you think about, you start at the bottom as you get on a Ferris wheel and you go around the circle, you're going to be going up and down, up and down. Now you may be saying, well, wait, this doesn't look like a Ferris wheel, but don't forget that our x-axis is time. Okay, and you can't ever go back in time, so our graph's never going to look like this, going in a circle. Right? What is happening is as time goes on, we're going up. Time goes on, we come back down. Time goes on, we go back up. Okay? So that's what this graph represents. So let's look at some of the questions. It says, how can you tell from this graph that the lowest part of the Ferris wheel is 2 meters off the ground? Well, if you look at the low points, in each case, it says that the height is 2 meters. Okay? So the graph goes down to 2 meters. What is the maximum value? In other words, how high do you go on the Ferris wheel? Well, again, you look at the highest point, our maximum, and it says we go up to 160 meters. Okay? Determine the range of the graph. Okay, range is our y value. So our range in this case is from 2 to 160. What does this mean? This means that the Ferris wheel, if we were to draw it here, goes from a low of 2 meters to a high of 160 meters. Okay? So that's what it represents. It represents the height of person on the Ferris wheel. Okay, determine the amplitude. Well, amplitude, if we look at the graph, is from the highest to the lowest. So somewhere in the middle here we have to have a midline. Well, we don't need to guess that. We know this is 158, right? From 2 to 160 is 158. And if we divide that by 2, this is going to give us 79 meters. So I know that if I go down 79 meters or up 79 meters, that's where the midline is going to be. So it should be right here at 81, right? 2 plus 79 would be 81. So the amplitude is 79 meters. Okay, so that's how much we go up and down from the midline. The equation of the midline is y equals 81. Okay, that's the average height. And the period. Okay, well, the easiest way to do the period is to either look at one of the low points or one of the high points and see when that happens again. In this case, it's pretty easy to see that the low point is from 0, and the next low point is at 30. So the period is 30, I think it's seconds. Right, is it seconds? No, it's minutes. Wow, it takes 30 minutes to go once around. So it says explain your method. What we just did is we looked at the low points, and when it repeats itself, that's when our period has occurred. What length of time is needed for the star of Nanchang to make one full revolution? Well, that's our period, 30 minutes. How long does it take to get to the top of the Ferris wheel from the bottom? Okay, well, from 0 to the top is 15 minutes. Okay. So kind of what this lesson is going to be about is going to be looking at graphs and try to do some interpretation on the graphs. So let's do example 1. The graph of a sinusoidal function is shown. Describe this graph by determining its range. Okay, so we're supposed to find the range. The equation of its midline, so y equals something. Its amplitude. And its period. So these are the things we're supposed to find. So the range is from the highest to the lowest. What are these values? It looks like it goes from -3 and up to 7. There's our range. So that's 10 units. So that means we should be going down 5 and up 5 to find our midline. So if I go down 5 from 7, if I go down 5, that means our midline should be at 2. So y equals 2. What is my amplitude? Well, that's half of the range. So that's going to be 5. And the period, how long does it take to repeat itself? Well, if we go from here to here, how far is this? Need to figure that out. Well, it looks like 2 squares is 120, so each square must be 60. So it looks like the period is 180 degrees. Okay. Let's try another one. This one's going to be backwards. So we're given the characteristics and we're supposed to draw a sketch. So it says the domain is from 0 to 360. So let's put 360 in here and then we'll already divide it up. Okay, I should know some of these divisions. I know 90, 180, 270. Okay. The range is from -5 up to 9. Okay, and the period is 120. Okay, so 120, that means I've got to put a few more marks in here. So let's divide these by thirds. So this is going to be 30, 60, 90, 120, and then I would have 150, then 210, 240, 270, 300, 330, 360. Okay, and it says the y-intercept is 2. By the way, you should be able to see that that is actually our midline. Okay, so I'm just going to sketch in a midline right there. So lots of information here. So if we're starting at 2 and it takes 120 to get back to 2, that should be right here. Okay, what's going on here? So that's one full period. So I need to be able to go to the top and to the bottom and get back to there. So how am I going to do that? You know that these graphs are supposed to be perfectly symmetrical. So I should be able to go up and back down and back up within 120 degrees. That means I must be crossing again here at 60. So it should go up, down, and back up again. Okay, this is going to be 90, -5. This is going to be 30, +9. Okay, and it says we're supposed to do a domain of 360, so this is going to happen a couple more times. Okay, so at 240, it's going to be back here, and at 360, it's going to be back here. We're also going to cross like this. So go down there, back up like this. Now remember, this is perfectly symmetrical, so you can always figure out what these points are. They're going to be right in the middle of our points like that. Okay? It might take you a couple of tries. What I would suggest right now is erase this and try it again to see if you can figure out exactly how I got some of those values. See if you can make sense of it for yourself. Okay? Let's try another one. The graph of the sinusoidal function is shown. Describe this graph by determining its range, the equation of the midline, its amplitude, and its period. Okay, so range from 2 down to -4. So the range is -4 to 2. That should give you where the midline is, right? If this is a space of 6, then we're going to go down 3, up 3 to figure out what the midline is. And that means the midline is going to be at -1. And our amplitude is 3. Okay? Now, the period is a little tricky because this needs to keep coming up here to get there. I don't know exactly where this is. Now, the good news is, though, that it is symmetrical. So if I can figure out what this is, 2.5, I know that this should be another 2.5. So the period is 5. Okay, so again, why did I do that? Well, I know that this is half the graph. This other half has to be exactly the same size. So if I was 2.5 on the first half, the second half also has to be 2.5. Okay. Another question. Range, equation of the midline, amplitude, and period. Okay, the range is from -0.5, -1.5. So always start with the smallest value. Right, we always go from the bottom up for the range. Okay, so this is a space of only 1 unit, which means that we're going to be going down half a unit and up half a unit. Our amplitude is 0.5. By the way, amplitude is always a positive value. Even though those are both negative numbers, amplitude will be positive. Okay, and then the midline is y equals 1. Sorry, -1. And the period, okay, how do you want to find the period here? It doesn't matter what you take as your first point. If you want to take this point and trace this along until you get to the lowest point again, you could do it that way. Okay, or you could have done it from, say, here's on the midline, and we'll trace it all the way until the midline here again. Whatever's easiest for you to figure out. Okay, I think it's going to make sense for us to go from here to here, and we see the period there is 2. Okay, example 5. For a physics project, Morgan and Lily had to graph and analyze an example of a simple harmonic motion. Morgan swung on a swing, and Lily used a motion detector to measure Morgan's height above the ground over time as she swung back and forth. The girls then graphed their data as shown. At the end of each cycle, the swing returned to its initial position, which resulted in a sinusoidal graph. Okay? So interpret the graph. Determine Morgan's height above the ground at 4 seconds. Well, first of all, interpret the graph. Let's take a look at what's going on here. At time is 0, the swing is at 2 meters high. Then you swing down and back up. Okay, so for A, let's list some of those things we were just doing. The range, what is the midline, what is the amplitude, and what is the period. Okay, so the range is going to be from here to here. Well, what is this first? I can see this is 2, but what is this value? Well, if that's 1 and there are 4 squares, this must be 0.75. Okay, so 0.75 to 2. That's the range. So that means you are swinging from a height of 0.75 meters to 2 meters. Okay, what is the midline? Well, that's going to be a little trickier because this is 1.25 and we have to divide that by 2 to figure out where the midline is. Okay, so 1.25 divided by 2 gives me 6.25. Sorry, 0.625. So that means I'm going down 0.625, up 0.625. Well, that's tricky. So to figure this out, I'm going to go 2 minus 0.625. So that will be 1.375. Okay. So that's going to be my midline, 1.375. So that's the average height. And the amplitude is 0.625, so that's what you're going up and down. The period, how quickly do you swing? Well, if we start at 2 and go back to 2, where is that? That looks like it takes 1.5 seconds to swing 1 time. Okay, so you think about going up and down back to the original spot, takes 1.5 seconds. That's what the period is. Okay, part B, determine Morgan's height above the ground at 4 seconds. Okay, so here's 4 seconds. It looks like 1 meter at 4 seconds. Okay, why don't you pause the video, see if you can answer this, and then we'll do it together. So if these are our 2 sets of data, how does this look different, or what looks the same? Well, you can see that the range is different. So the second swing, you'll be going a little bit higher. So second swing goes higher. So the second swing goes higher. You could say by 0.5 meters. Okay. The second swing has a bigger period. So what does that mean? The second swing has a longer period, which I guess should make sense because it's swinging higher, so it takes a little longer to get to that higher height. Okay, so I guess if this was a test question, I would look at how many marks you're being given. If it's a 2-mark question, you would want to come up with 2 things to compare. Okay, so we'll leave it at that. All right. Similar question. I think we'll leave this one. I think you're probably getting used to it. You can try this question. Maybe we'll even take that up in class. So I'll leave that for now. What I'd like you to do is do the homework here for 8.3. Okay, so there's a whole bunch of questions in here. Just want to see where it stops. All right, stops right there. Okay, if you could get that done before the next lesson. Thanks.